Okay, Bismillahirrahmanirrahim. Okay, folks, welcome back to our GCSE class. We're looking at similar shapes today. Grade C, Maths Watch, clip 123. We've got a typical style of examination question here. On the left-hand side, I'm going to just draw a quick sketch of it if I need to on the left-hand side. Right, let's have a quick sketch. So what we're going to do here, here's our first shape, this top one here, and then I'm going to draw the bigger one over here on the side. Just a quick sketch. Okay, right. So I need you to be copying that down on your piece of paper and your books, please. Remember, you're not coming here to, it's not movie time. You're not just watching the screen, you need to be doing work as well. So let's write down, put some details on it. So Mr. Honey, have you been given a book?
Yes.
Okay, you've written down the title, similar shapes, you've done the sketch?
No.
Okay, do it quickly, please, young man. 12.5 and A to C is 15. Okay, and they say C to E is 6. So if C to E is 6, what's 6 add 15 to get the full distance? What is it? 21. Okay, so the question is basically that. Put it one side, just put it behind you for a moment. Okay, be careful, don't open the door, don't slam everything and go slam the floor. Just put it one side, so it's safe. Okay, so here's the question that we have on the left hand side. I've done a sketch of it on the right hand side. Now, it says work out the length of DE. Well, DE is this bottom length here. Okay, in order for us to work out the length of DE, we need to first establish the scale factor. So let's have a look at how we do this. So we have a length of our original multiplied by the scale factor is equal to the length of the enlarged. So this is our original shape. This is our enlarged shape. So the length of original, so we need to find two corresponding lengths. So, Mr. Hamza, what corresponds to 15 in the second diagram? 21. Well done. So the number 15, this length here corresponds to this length. So it has increased by a scale factor. We multiplied it by a multiplier. So the length of the original is equal to what? 15. Multiplied by the scale factor, which we don't know for the moment. And that will give us the length of the enlarged, which is equal to 21. Okay, that will give us 21. Now, if you want to work out the scale factor, honey, what do? We want to work out the scale factor. Divide. So what do? Opposite of time by 15 is divide by 15. So the scale factor is equal to 21 divided by 15. Anybody got a calculator with them at the moment? Quickly work that out for me, please.
1.4.
Exactly.
Yeah.
Okay. So that gives us 1.4. That's not recurring, just 1.4, yeah? Lovely. That's our scale factor. Now that we know the scale factor, we can actually work out this missing length here, which they call DE. So what do we have? Okay. Right. Now we're going to work out the DE. So, Mr. Honey, what corresponds to the DE on the small shape?
12.5.
12.5. So we say now, again, so it's still the length of the original. Time by the scale factor is equal to the length of the enlarged. So this is our rule for when we're dealing with lengths. Now the length of the original is 12.5. The scale factor we have just worked out, which is 1.4. And that will give us the length of the enlarged. That will give us the length DE. Okay, so Ikra, you've got a calculator there? You're working out for me? 17.5. Can I have another confirmation of that?
17.5.
Okay, thank you, Mr. Saf. So the answer here we're getting here is 17.5 centimeters is the length of DE. And that's a typical examination style question when we're dealing with similar shapes. And most of the time the questions to do with lengths. But we also do get questions to do with area and volume. Okay, but that's a typical length one. I'll be happy with that. Have you copied all the notes down? Yeah? Has everybody got the notes? I'm blank the page and I'll go through the question. Yeah. Okay, lovely. So, alright, okay, let's move this down a bit. Whoops. Oh, I don't think I wanted to do that much. Okay, just give me a moment while I get my page back. And that's just another question which is similar, which I'll give you to do in a second. Question number 2. Let's move on to a different looking question. Okay. Okay, here we go. Let's make it a bit bigger. Here's another example. Okay, now I'm going to do a little sketch over here on the side because I can't actually write this at the moment. So that's why I've got 2 things open. So I'm going to do a little one. And then I'm going to draw a bigger one. I'm just drawing a quick sketch. I'm not using ruler in the house just to save time. PQ. AB. CD. Similarly, if you guys can save a bit of time for just a little sketch that I will do for the moment. This one is 8 centimeters. This one is 21 centimeters. And this one is 14 centimeters. And this one is also 4 centimeters here. Now, it says that the diagram shows 2 quadrilaterals that are mathematically similar. Calculate the length of AB. So we first of all need to work out, oops, I want to use the red and I got a gray. We got to work out this length here. Now in order for me to work out that length there, we still use the same rule. Length of the original time by the scale factor is equal to the length of the enlarged. Okay, so that's our basic rule is works. Now, let's have a look. We're looking for 2 corresponding lengths at the moment to work out what the scale factor is. That's the question. Before we can do that question, we've got to work out a scale factor. So, Samara, can you give me 2 lengths which correspond on the diagram?
4 and 14.
Lovely. 4 and 14. So, what do I mean by 4 and 14, Mr. Honey? Are we here?
Yeah.
Okay. Why is 4 and 14 corresponding? Because SR is on the bottom and DC is also at the bottom. They both correspond. They're in the same position. So here we go. So under the LO, we are going to put 4. And then we're going to work out the scale factor. Quickly. And then we're going to work out and so that gives me length enlarged, which is the 14. So I've got to work out the scale factor. So opposite of time in the scale factor by 4 is divided by 4. So the scale factor is equal to 14 divided by 4, which is what? 3.5 exactly?
Yeah.
Okay. Mr. Saf, can you confirm that for us as well, please?
Yeah.
Lovely. Oops, no, that's centimeters, 3.5. So the scale factor is 3.5 by looking at the information which I've circled in orange. So we establish that first before we can actually do the question. So this is called a goal problem. So before you can do the question set, you have to do something else first. Okay? So let's have a look at our question now. Again, use the same idea. Length of the original time by the scale factor is equal to the length of the enlarged. So what was our length of original in the question here now? It is 8. And we're going to multiply it by the scale factor and we're going to get what length now? What's called? Length is called AB. So 8 multiplied by the scale factor. What is the scale factor? We get it from here and we put it into here. So time by 3.5 is equal to LE. The length of the enlarged is actually AB. So what is 8 times by 3.5?
28.
28 centimeters is equal to the AB. And that's the end of that second example. And now I want to get you to do some of the questions. Are we happy with the examples, folks? Yeah? We establish the scale factor and then we go and do the question that set us. So this is to do with the length style. Now, when you do the questions, please can you make sure, I'll be walking around the room. Please can you make sure that you are doing these formulas in here. Showing me them, okay? Right. Okay, right. I'm just going to pause it there while I give you some questions to do. Okay, folks, I just realized we missed out question B. You've got to work out the value of PS. Now, if you look at the diagram, PS is here and AD is there. So we say again, the formula is say length of the original multiplied by the scale factor is equal to the length of the enlarged. So what is the length of the original? Length of the original is what? PS, which is this one. We multiply that by the scale factor, which we worked out earlier, was 3.5. And that will give us the length of the enlarged one, which is, sorry, 21. Yeah? Happy with that? So PS relates to 21. It correspond. So that will give you 21. So if I want to work out PS, what we do is opposite time by 3.5 is
Divide by 3.5.
divide by 3.5.
6.
So PS is equal to 21 divided by 3.5, which gives us 6 exactly. So in this particular question, we have to do a division calculation. We have to do reverse in order to work out the answer. And that will be the answer to part B now. So that is part B. And that's the end of that particular one now. Okay, here we go. This is the question I gave you folks to do for classwork. So let's do a quick sketch of our situation. We have a small triangle and a big triangle. So this length is 10. This is 6. This total length is 10 add 5, which is 15. It says they work out the length of DC. DC is which one? That's DC in the diagram. Now, in order for us to work out DC, we have to work out the scale factor. So we look at two corresponding lengths and work out what was the scale factor. So the length of the original time by the scale factor is equal to length of the enlarged. Okay. Now what is the length of the original? It is 10. Time by something is equal to 15. So that something is equal to what? 1.5. So that's our scale factor. Lovely. Now we can use the scale factor to work out how do we get from here to here. Them two are also corresponding sides. So again, length of the original time by the scale factor is equal to length of the enlarged. Do not underestimate the power and the importance of actually writing the formula each time. It's important. So I'm not just writing it for fun or to tease you. I'm writing down because it's important. So 6 is the original length. The scale factor we've just worked out is 1.5, and the length of the original is DC. So 6 times by 1.5 is equal to 9. And that's the end of part A. Work out the length of DC. Now, part B says work out the area of the trapezium EBCD. So which is, if you follow where my hand is here, that the cursor, that's this part of the diagram. Okay, are we happy with the first part? Because I need to clear the page because I don't have any more space. You happy with the first part? Have you got that down?
Yeah.
Okay, good. So, if I just quickly sketch for you the second part of the diagram that we're interested in. Okay, this is parallel. This is a trapezium. These are your parallel sides. That's your vertical height. That's 5. That's 6. What's the bottom one?
9.
9. Now to work at the area of a trapezium, who knows the area of a trapezium? What's the rule?
Me.
Come on, give me formula, please.
Half.
Area is equal to,
Half.
okay, A plus B divided by
2.
2 multiplied by
H.
height.
I was thinking to say that.
Okay, the A value is one of the parallel sides and the B value is the other parallel side. And the height is here. So that's our rule for the area of trapezium. Let's put the values in. What is the A value? The A value is,
6.
and the B value is,
9.
so 6 at 9 divided by 2 times by the height is 5. So 6 at 9 is 15 divided by 2 is 7.5 times by 5 is
37.
so that is the area of the trapezium EBCD. Okay, are we happy with that now? So we had a little bit of area question thrown in as well. So that was the context of the question. Are we happy that you ready to move on? Good.